So let's have a look at trapezoidal rule. I know that it might not be that difficult. However, it can be proven challenging. Okay, so let's see. The graph of the function f in the domain. Now, what does that mean? Let's break it down. So I have function, the name of the function is f. In the domain -2 less equal x or greater equal 3. Now, what does that mean? Basically, what that means that the x values goes from -2 to 3. And we can see that they go from -2 to 3. Exactly, that's what it means, just written in a fancy mathematical way. So it's shown on the diagram on the right. The graph is symmetrical. What does that mean? That if I here in the middle, oops, didn't come out very straight, this is the axis of symmetry. So basically, if I take this graph and fold it, it will fold exactly, cover itself. Is absolutely one part is exactly the same as the other part. Okay, so what do we need to do? We need to use the points shown on the graph to complete the table below. Okay, that's simple enough. We have the first one done. From -1, we go to the point and we read that's 4. 0 and 6 is done. Again, 1. We go all the way to the graph and we read that is 6 again. And then 2 we have, and then 3 is 0. So that was simple enough. Now, the main part. So they are saying use the trapezoidal rule to estimate the area between the graph and the x-axis. Use the values of fx from your table as your heights. So that we are calculating that area. Okay. So let's get our formula from our table. We have that trapezoidal rule. And the problem, like I'm saying, the problem with this formula, sometimes there are some items that can be causing a little bit of difficulty. So let's talk about that. Okay. Now, the way this formula works is that this y here, all of them, they represent the height or the length or the distance, however you want to call it. The point is that it is a distance here. So when we have, okay, let's remove all of this drawing and let me explain. If I have irregular shape, I'm saying to myself, I'm going to divide it into like parts, like stripes, right? And I'm going to kind of consider each of them separate. That's basically what that idea of trapezoidal rule, that's the way it is working. So the y's in our formula represent this length every time. Now, where we can get caught in this type of situation is about the first and the last y. Because here, this is where it starts. This one here is my y1. This one here is y2. This one here, y3. Then we have y4. Then we have y5. And this one here is the last, in this case, y6. So that's not to get caught. Just because we can't see them, like they're not there, that doesn't mean they are not there. We have to consider them. Okay. So in this formula, that y1, that's always the first length or the height, and that yn is the last one. Now, what you have in bracket here are all in between. In our case, it will be 2, 3, 4, and 5. So 2 and 3 and 4 and 5. So they all will go into that bracket here. This is the first one. This is the last one, the sixth one. So where do we get those values? And the reason why in your formula they are letter Y, because it's actually letter Y here. Those are the values, especially when you have a table given. So this will be your y1, y2, y3, y4, y5, y6, the first, the last, and all in between. Now, what about that h? What does that h mean in our formula? So that h, what it means, well, those equal kind of stripes that you've done, that you divided, well, what is the length of that? That's basically what is asking. So in our case, that distance here between those values will be 1. So now all we have to do here now is to replace those letters with numbers. So 1 divided by 2, our first, where is our table? Maybe let's write it here. 1 over 2. Our first one is 0 plus our last one is 0. That's what I'm saying. Just because we don't see them, that doesn't mean they are not there. In maths, when something is, when we have nothing, what do we say? 0. That's what I always tell you. Okay, and then 2 multiply and all those in between. So 4 plus 6 plus 6 plus 4. And now all of that goes into your calculator. You press equal and you get 20. And 20 is that 20 square units. That's the area here between the graph of the function and the x-axis.